Okay, trig integrals. Let us evaluate the integral of cos cubed x dx. I don't know. Yeah. You'll get large for a medium charge. So we can't do a U substitution, right? I mean, if we let U be cos x, then we're going to get a sine x, right? So we can't do a U substitution. We can't. Wow, not a good U. Can't do a U substitution, right? Because if we let U equal cos x, then we get du is equal to minus sine x dx, and so we got a dx there, but there's no minus sine x, right? So we can't do a U substitution. Because we don't have a sine x in the original, right? We don't have a sine x.
So if there was an x, we could.
If there were a sine x, then yeah, we could, right? Because then, we look, U substitution idea is, hey, can I, hey, du, so if I had like a minus sine x dx up there, boom, I just replace it with du. And then we would write U cubed d, but we don't. So here's the question, what are we going to do? If we had a power of sine, so this is a power of cos. If we had a power of sine, we would need a cos in there, right? Because the derivative of sine is cos. So if we had like sine cubed, we'd need a cos. So if we had a power of sine, so this is really dealing with trig powers, right? If we had a power of sine, we would need a cos x factor. The x factor. All right. So here's what we can do. What if we did this? We look at it, we say cos cubed x is equal to cos squared x times cos x, right? This is true. Yeah. And what's cos squared x? The most famous of the identities. 1 minus sine squared x times cos x. So what if we let u equal sine x? Then du would be cos x dx. And we got a cos x, right? Okay, so let's try this. So if we let u equal sine x, then du is equal to cos x dx. So let's go back to the original. And the original was cos cubed x, so the integral of cos cubed x dx. So we're going to say, all right, I'm going to write that as the integral of cos squared x times cos x dx. And I'm going to write that as the integral of 1 minus sine squared x cos x dx. And now we can see that du is cos x dx. So this is du. And if u is sine x, then this is 1 minus u squared. And that we can do, right? Like, that's easy. All right, so let's extend the page a bit and do that. So so that will become the integral of 1 minus u squared du. Okay, so u is sine x, 1 minus u squared. Du is cos x dx, so the cos x dx is du. That integral is pretty easy, right? So it's just u minus 1/3 u cubed, and on the end, plus c. And then we say, but it wasn't really a u to begin with. U is sine x, so this is sine x minus 1/3 sine cubed x plus c. And that's the integral of cos cubed x dx. Within foot reach. Okay, we good with this? So, what do we want to do? We want to write an integral involving powers of sine and cosine so that we have only one sine or one cosine and the remainder in terms of cosine or sine, right? So you want one sine or cosine, so you've got a cos x dx or a sine x dx, right? Which means we let u be this, and then we've got a nice du. So that's what we want to do, right? So we want to write an integral involving powers of sine and cosine so that we have only one sine, so or cosine, right? So a single sine or cosine, and the remainder in terms of cosine. So if we have only one sine, we want the remainder in terms of cosine. If we have only one cosine, then we want the remainder in terms of sine. Right, which was the example we did. So we had one cosine, right? Cos x dx, and the remainder was in terms of sine. All right, what does that look like? So let's do this. So we have sine to the fifth x, cos squared x dx. Now, if we convert cos squared x to 1 minus sine squared x, then we won't have a cos, right? It'll just be sine, right? You like sine to the fifth minus sine to the seventh or something, right? We can't do that. We need to have a single sine, single cosine. So that's just if we convert cos squared x to 1 minus sine squared x, we won't have a cos x. Okay, so we need a cos x, right? A single cos x or a single sine x. So here's what we're going to do. We're going to split the odd power. So split the odd power. So what's that going to look like? Well, we've got sine to the fifth. That's the odd power. So here's what we've got. Okay, so all I'm doing is working with this, right? We're removing the integral sign. We're just going to say, all right, let's work with the expression, the sine to the fifth x cos squared. We're going to split the odd power, sine to the fifth, and write it as sine squared x squared. Right, which is what power? 4, right? So that's sine to the fourth x. And then we've got a cos squared x, and we've got a single sine x. All right, so sine squared squared, what's sine squared x? Basic trig is 1 minus cos squared, right? So this will become 1 minus cos squared x squared times cos squared x times sine x Okay, so we've still got that single sine x, and the rest of it's in terms of cos x, right? So that's good. All right, so where do we go from here? We're going to let u equal cos x.
I want to be cos x.
Then du is going to be minus sine x dx. Okay, so remember this is part. So let's go rewrite the integral, right? So the integral of sine to the fifth x cos squared x dx is equal to the integral of sine squared x quantity squared times cos squared x times sine x dx. Okay, so we are repeating what we did here. This is sort of, whoops. This part here is the thinking, and now we're just saying, okay, you know, we see where this is going to lead, so now let's do it. So you don't have to show this part. In future, you'll just go straight to here, which is the integral. So sine squared x, we're replacing it with 1 minus cos squared x squared times cos squared x times sine x dx. Okay, so we split the odd power into an even power, sine squared squared, and a sine x, right? Because this is what we need, right? We're looking and say, hey, I need this. But then if I need this, then I need the rest of it to be in terms of cosine. Okay, well it is now. Okay, now we can do the u substitution. So it's 1 minus u squared, quantity squared, times u squared times du, right? Sine x dx.
Isn't it times negative du?
You're right, times negative du. Yeah, we will. We'll do that on the next line. Good catch. As if I did that on purpose. All right, so now we can move the negative sign out front, and we can combine what we have here, right? Like we could just do this. So negative, the integral of, okay, what's 1 minus u squared squared? 1 minus 2 or 4? 2 minus 2u squared plus u to the fourth, right? So 1 minus 2u squared plus u to the fourth times u squared and the du. Okay, let's take the u squared in there. So we've got minus the integral of u squared minus 2u to the fourth plus u to the sixth du. Almost trivial, right? I mean, we're just adding 1 to the power and dividing by the number now. So to find this integral, so this is easy, right? It's just u's and it's just powers. So it's negative, okay, u squared, u cubed over 3. Minus 2u to the fourth, so we're going to go up to a 5, so it's going to be 2 fifths, u to the fifth, plus 1 seventh, u to the seventh. I need, yeah, brackets. And on the end, plus c. Equals, but what's u? No, what do we say? Let u equal cos x. All right, so replacing u with cos x and distributing the negative sign through the brackets gives us negative 1/3 cos cubed x plus 2 fifths cos to the fifth x minus 1 seventh cos to the seventh x plus c. Right. We're a third of the way through. Yeah. What is it? 1/3. Actually, a little bit more than a third. Oh, I can't read the word in the upper right. The staples on top right. So. Okay, that works for odd powers, right? To separate it as a factor. What about an even power? So that works for an odd power.
It's not quite as trivial with this now.
Yeah. Yeah, this is less trivial, but this uses an identity. And what we're about to do isn't on your formula sheet, but it's very easily derived from, and not that derivative thing derived. It comes from something that is on your formula sheet. Okay, so we're going to look at this. So that works for an odd power to separate it out. What about an even power? Question mark. So what we're going to do is we're going to use the half-angle identities. I know that it's not something you did in 30-1. But they come from what you did. So the half-angle identities works like this, right? Cos of 2x, written in terms of cosine, is 2 cos squared x minus 1. Which means we are going to write 2 cos squared x, just add 1 to that side, is going to be 1 plus cos 2x. And then cos squared x is going to be half of this. So cos squared x is 1/2 of 1 plus cos 2x. And kind of the important thing we're looking at here, well, number one is kind of knowing this or being able to get this, right? So you just got to say, all right, I got to get a cos squared x, right? Because that's the even power. And the other thing to look at here is that whatever's here, this is double, right? So whatever's in front here, so if you have cos squared of blah, this is plus cos of 2 blah, right? So if this is 8x, what's this? That'll be a 4x, right? Be half of. So whatever's here, this is doubled, or whatever's here, if you have an expression where you've got a cos 8x, you can rewrite that, so you got a cos squared 4x, right? So you have 1 plus cos 8x. So just remember that relation. And the other one is, so this is, what if I have an even power of cos, right? Cos squared, then we're going to use this. What if I have an even power of sine? So cos 2x again, this time is 1 minus 2 sine squared x. Okay, pretty sure that's on your formula sheet, right? You've got the cos 2x formula. So, all right, what if we have an even power? So if we've got 2 sine squared x, we'll move that over, then this will be 1 minus cos 2x. So sine squared x is equal to 1/2 of this quantity. Okay, and the same relation, right? Like whatever's here, this is twice as big. Okay, or whatever's here, this is half of whatever's there. Okay, so using those, let's get to a new page. Evaluate. So evaluate means find out value, right? So we've got a definite integral going from 0 to pi of sine squared x dx. So where do we start? Well, we start by replacing sine squared with 1/2 of 1 minus. Okay, so here, that's the question. Here's what we're going to write. 0 to pi of sine squared x dx is equal to the integral from 0 to pi of 1/2 1 minus cos 2x dx. which is equal to. Well, actually, we can evaluate that now, right? So let's just do this. So this is doable, right? I mean, we can find that integral. There's no U-substitution. Well, it is, you know, kind of implied, but easy. So the integral of 1 is x. Integral of cos 2x, you could do a U-substitution on the 2x, but we're not going to do that. No point. Yeah, minus 1/2 sine 2x, right? So think of this as like guess and check. Okay, I think it's got to have a sine 2x, right? So the derivative of sine 2x is cos 2x, but then I've got the 2 coming out, so I got to do a half of that, right? So just double check by doing the derivative of this, make sure you get the minus cos 2x, right? Signs are correct and so on. And that's going to be evaluated from 0 to pi. And so now we plug in. So we got a half. Okay, so what do we got? Pi minus 1/2 sine 2 pi minus 0 minus 1/2 sine of 2 times 0. All right, what's the sine of 2 pi? That's just 0, right? What's 0? That's just 0. What's the sine of 2 times 0? 0. 0. So what do we got? A half times pi, 0, 0, 0, 0. So it's just 1/2 pi. Pi over 2. Or 1/2 pi. Okay, so given an even power, sine squared, we use the half angle identity, right? 1/2, 1 minus cos 2x. That, you could just do the derivative of that right off the bat. All right, let's try this one. So 0 to pi, cos to the 4th of 2x dx. All right, what are we going to do with that? Well, so it's an even power, right? So we're going to write that as cos squared 2x squared dx. Okay, so we'll go with cos squared squared. Right? So we want an even power, but we want it to be a squared. What do we do with cos squared? So we know that cos squared is 1/2 1 plus cos. Okay, so what do we do with the 2x? So it becomes 4x, right? So what's here gets doubled, right? And that's squared and dx. All right, so the half is being squared, so it's going to be a quarter, and it's a constant, so we'll just move it out front. Okay, so this is being squared, and when it is, it will become 1/4. Then this is being squared, okay, so we just square it, right? 1 plus 2 times cos 4x plus cos squared 4x. So bracket. So now we're going to square this. So we squared the half, but we kicked it out front. We're going to square 1 plus cos 4x. 1 plus 2 cos 4x plus cos squared 4x dx. All right, well, we're looking at a cos squared again, right? We're going to use the half angle identity. I've got a cos squared. I'm going to replace it with 1 plus cos of, and we'll figure that out. So we got 1 plus 2 cos 4x plus. Okay, so the half angle identity is 1/2 of 1 plus cos of what? cos squared 4x. What do we do with 4x? Double it. So it's going to be 8x, right? Dx. Okay, now everything in here is doable, right? But let's clean it up just a little bit. We'll move. Okay, so we'll stick with the 1/4. 0 to pi. Just going to clean up what we've got in here. So what's that going to be? So we got 1. So we got a half here, right? So we've got 1 plus 1/2. So that's going to be 3/2. We've got the 2 cos 4x. And we've got 1/2 of cos 8x. Okay, so we distributed the half through, that gave us a 1/2, which got added to this 1, became 3/2. And we've got the 2 cos 4x, and we've got 1/2 of cos 8x dx. And now, we can actually do the integral. So 3/2 becomes 3/2 x. Cos 4x, well, you're going to have to start with sine 4x, right? Derivative of sine 4x is cos 4x, good. And we've got that 2 in front, but we're multiplying by 4, so 1/2, right? So we've got to turn that 2, right, or the 4 that's going to come out of that has to become a 2, so we got 1/2, and derivative of sine, or sorry, derivative of sine is cos, right? So sine 4x derivative is 4 cos 4x. We want that to be a 2. We throw a half in. Cos 8x, you're going to need a sine 8x. But you're going to get an 8 coming out, and we want it to become a half, so yeah. So 1/16, right? And then the 8 times 1/16 gives you the 1/2. And we don't need a plus c, right? Because it's a definite integral, so we are evaluating that from 0 to pi. Now, before we substitute in, you think, what are we going to have? 4 pi. What's 4 pi? What's sine 4 pi? 0. 8 pi? 0. Okay, so this is going to be 0, this is going to be 0. This will be 3/2 pi, right? This will be 0, this will be 0. When this is 0, 0, sine of 4 times 0 is 0, 0, right? Everything zeroes out. Okay? So it's really just going to be 1/4 times 3/2 pi, right? Which is 3/8 pi. Okay. Now, but let's write it out. I mean, it doesn't hurt to write it out. So we've got 1/4. We know where it's going. So we got 1/4 of, okay, now we put the pi in, so 3/2 pi plus 1/2 sine 4 pi plus 1/16 sine 8 pi. Let's throw that in a set of brackets. Minus 3/2 times 0 plus 1/2 sine 0 plus 1/16 sine 0. And we can go through this and just say, that's a 0, that's a 0, that's a 0, that's a 0, that's a 0. So what do we got, really? Just 3/8 pi. Or 3 pi over 8. All right, now what we're going to do is summarize it, and we're done. In summary. Okay, so here's your strategy, or the strategy, which is the summary. Strategy for evaluating the integral. Why is it written so small?
It's not a question, it's a conclusion.
This is just the conclusion. I just need, it's like small writing. Sine to the mx, so the integral of sine to the power mx cos to the power of nx dx. Okay, three possibilities. If the power of cosine is odd, another way to say that is if n is equal to 2k plus 1. Right? That makes an odd number, right? You take k is any number, you double it, it's now an even number, you add 1, it's now an odd number. Okay? So if it's odd, then what you want to do is you want to save one cosine factor. Save one cosine factor. Okay, we'll take the even ones, the largest even, right, and just have one remaining. So if it was cos cubed, we want cos squared and then cos x. If it's cos to the fifth, you want a cos to the fourth and a cos x. So you save one cosine factor and use cos squared x is equal to 1 minus sine squared x to express the remaining factor, to express the remaining factors in terms of sine. And then you do this. So it'll look like this. The integral of sine to the m cos to the 2k plus 1 dx, okay, so that's the odd number, right, is equal to the integral of sine to the m times the cos squared x to the power k, right? So we're taking the even power, writing it as cos squared x to the power k, which is cos to the 2k, times cos x dx, right? Which we're then going to turn into sine to the m. I think I'm missing x's here, right? There should be an x there, and an x there, and an x there. Yeah, sorry. Bad writing. Sine to the m x. The cos squared becomes 1 minus sine squared x to the power k. Right, so cos squared is replaced by 1 minus sine squared. And we've got the cos x dx. Okay, and then you use a U-substitution. Then use u is equal to sine x. Right, so if you use u equals sine x, then du is cos x dx. So this just becomes a cos x dx. This is u to the m, and this is 1 minus u squared to the power of k. And you can just work that out. Okay, then everything's in terms of u, and they're just powers of u, and that's pretty easy. Now, if you like, we could rewrite the exact same thing, saying if the power of sine is odd, m equals 2k plus 1, save one sine factor and use, sine squared is equal to 1 minus cos squared, and express the remaining factors in terms of cosine. So do you want me to write it out, or you good? You just, everywhere you see cosine, you put sine. Everywhere you see n, you put m, and write it out. But you don't use, well, then you can use U-substitution on u equals cos x. And if both powers are odd, use a or b, right? Like your choice. Okay, so if both powers are odd, just choose one. Get it in terms of all sine with the cos x dx, or get it in terms of cos with the sine x dx. And the important thing just being that you've got one of these guys, right? Either cos x dx or sine x dx. Okay. So do you want b written out, or you'll just do your transposition? No? Good enough. Just takes one person to say it. Okay. B, as above. Replace cosine with sine. cosine, and m with n with m. N with m. Last possibility. What if they're even? So if the powers of both sine and cosine are even. Of both sine and cosine are even, use the half angle identities. Okay, so if it's odd, you get it as an even with one remaining, one single, right? So you got a cos x dx or a sin x dx. U-substitution, powers of u, and away you go. If they're both even, then you use a half angle identity, okay? And those are that sine squared x is 1/2 1 minus cos 2x, and that cos squared x is 1/2 1 plus cos 2x. Okay, so just remember, whatever's here, this is double. And sometimes you can use this. Sometimes here. That sine x cos x is 1/2 of sine 2x. Okay. That's on your formula sheet, right? But you got sine 2x is 2 sine x cos x. So then take a half everything. Okay, say 2. So I think the questions, I don't know, now I think questions are like 519 or something.